Hey, hello, how are you doing today? Welcome to my another stream talk about functional programming. In particular, this will be about functional programming is mainstream. I want to articulate that it's no longer a niche paradigm. It's no longer even a paradigm itself because it's a style of programming that is embedded into most of our mainstream languages. Moreover, we deal with functional programming more often than we know about that because functional programming today is a core technology of many other technologies, and we can even recognize functional ideas in what we did in the past without realizing we do functional programming. Even when FP wasn't mainstream, even it wasn't uh, so popular in the mainstream languages, there was still some occurrences of functional programming that we can now say with full responsibility that it was functional programming. So what I want to tell you about today, it will be a talk about small features and functional programming in different languages, because we can actually talk about functional programming as small and in large, but it's two different topics and they require a vastly different approach to teach. So today we will be talking about functional programming in small. Sometimes people conflate functional programming and three functions, which are map, filter, and reduce. This is a schematic representation of those functions. Map takes some collection and produces another collection while altering each item with a given function. There is a function, in this time it's cook, and there are items to the left, and each item will be transformed by this function. This is what the map function does. It's a classic functional programming tool, but it's not the only one, right? The same story about filter. Filter takes a collection and removes some items that do not match with the conditional argument. Actually, we did this quite much in our languages because we had sorting algorithms that take some conditional operator, right? And we could do filtering and other similar functions. So it's not quite new to us. And reduce may be in another famous function from FP. It takes a collection of items and calculates some statistics over those items. It somehow produces a common result of those items. Maybe it can summate them, like add all those items together and get a single result. It can divide those things on something. It can do other things to convert this list of things to a single item. So those are three functions that we know from functional programming, but actually it's not functional programming in general. It's a part of functional programming, but not what FP has entirely. So we actually have many things from functional programming. As I said, there is division in FP in small and FP in large. When we are coding and using FP ideas, it's FP in small: purity, immutability, lambdas for sure, first class and higher order functions, also collection processing, hopefully algebraic data types, and pattern matching. Not all languages have that, unfortunately. When we are talking about constructing whole systems with functional programming ideas, it's functional programming in large. We can use declarativity, we can apply functional architectures, design patterns specifically suitable for functional languages, idioms, EDSLs, and other things. So yes, we will focus on FP in small. I want to emphasize the point that it's everywhere, and we do not need to learn some exotic languages to do functional programming. So functional programming in small. Let me highlight the core difference between functional programming and imperative programming. In here you see an imperative script. It's written in a language similar to C++, and you can see many operations here, statements. Each statement is a thing in its own. It's fixated, immutable, I would say, statement about what to do. Immutable means it cannot be moved. It's there in the code and it will be there forever, right? Because they are like nailed labels in the listing of the code. They are not movable. But we are very accustomed to this kind of programming, so we can read it and can understand this kind of script easier than functional counterpart. And functional counterpart may look like this. It's not the only way to write this code in functional way. There are various sub-styles of functional programming, but it can be. And maybe this particular example is not very representative of a functional programming, but it still shows that in FP we don't have statements, we have expressions, and they can be represented, demonstrated as a pyramid of calls. So we construct tree-like structures, tree-like expressions from our code. And what's more interesting and more important is that our functional idioms and items, they are not nailed down to the mental model of our program. They are movable. Every functional piece can be stored in a value, can be passed into another value. They can be moved. They are flexible, and they are not statements. They are expressions, regular values. So functional programs are mostly values, and then we can think about them as values transformations. This is a very important difference, and it affects all the ways we write the code. And for sure, the most important feature of every functional style is lambdas. Mostly they can be found in many programming languages. They exist everywhere, and we also can mimic them if they don't exist. For example, in C++, we can mimic them with so-called functor objects. It's an ancient technique, I would say, in C++ that could be used to mimic lambdas. But why do that if we have lambdas themselves, right, in various languages? And yes, in this form, we can mostly use them for collection processing. It's the most convenient and spread usage. We pass lambdas to collections and to functions. For example, sorting function, we can pass a lambda that defines ordering, and it will be called eventually by the sorting algorithm. So this is not new to us, right? Let me first present you the feel and look of functional programming in Haskell, and then we discuss other languages too. In Haskell, we can say it's the most idiomatic and rich functional programming from most of the languages. Today, Haskell feels like it's the main FP language and also very strange one, right? But actually, on the basic level, Haskell is not scary. Haskell is a difficult language, that's true. Don't be confused by folks who say Haskell is simple, because there is a nuance here. Haskell is simple on the basic level, but the more you climb to the abstract things, especially those things that Haskellers love, the more difficult it becomes, and it can even compete with C++ and Scala in this sense. Well, but here we see a simple program that defines numbers, then gets only even numbers, and then gets squared numbers from that filtered set, and then prints them. This is a step-by-step definition of the program. Well, actually, it's not step by step when it's compiled. It's still an expression. It's just written like so, and we can read it sequentially, right? Also, notice that in Haskell, in Haskell, we have functions and we have arguments passed without any syntax. They are separated by only spaces. This is not just an arbitrary choice. This hugely helps for doing functional programming, because in functional programming, when you have a function, for example, a filter, this time it's two arguments function, you can actually treat it as a function of less arguments. It can be a filter of one argument, but then it will return another function of another argument. All the arguments will be there, but the fact that every function is not nailed down to the code, it can be transformed. It can be carried in saying in the scientific language. You can take out an argument and get another function made from the previous one, and having only spaces between arguments and the function itself helps to flexibly construct more functions from the existing one, and this hugely helps to functional programming. But as I said, this is an expression, and I can actually write it in one line. Again, there is a list. It's called list comprehension. It can define a list from 1 to 10. It will be expanded to 1 to 10. A very known idea to, for example, Python programmers, right? Even is another function, and so filter accepts even as a function and a collection, and then produces another collection. Again, map is that function we know about. It gets again a function. This is a function of squaring, and gets a collection from here, and print gets the result in this time it's a collection again. So we can write one-liners or tree-like expressions with functional programming. This is only a small example of what we can do for sure. I won't be able to teach you to Haskell at all, but anyway, the idea that we have some tickets, I would say, some movable objects, or maybe, well, functions actually, that can be applied one to another is the core of functional programming, right? So we have a filter ticket, it has two slots, and we can put some correct things into those slots, and this ticket itself can be put into another ticket, and etc. and etc. So this is how we feel doing functional programming. We also can use lambdas instead of special form of function. This is a special form of function in Haskell. It's one argument function that has an argument here before this strange sign. It's a convention. There is an argument before the squaring, and we can expand it using lambda. There is a lambda, it gets one argument, and well, actually I could write squared here like before, but prefer to multiply it by itself. So lambdas are functions too, and they also can be moved here and there, and they are tickets. Yeah, if you want to learn functional programming, maybe Haskell will be the best choice apart the choice of your personal language, because I'm sure your language has functional programming. But if not, you can learn Haskell on the basic level and you will get the idea. And it's not very difficult. I would recommend avoid doing mathematical functional programming because it exists in nature, but it's not the best way to enter to functional programming. I would say it's a bad way to enter to learn FP. Maybe I would say simple, more grounded functional programming will be more accessible than mathematical one. Let's talk about C++, because C++ it's not one language. C++ actually is the most difficult language of all, and it has at least 4 sub-languages. One is regular C++ that is derived from C. Another is macro programming that is also it's presented in C, I believe. Also, there is a template metaprogramming in C++. It's a completely different world. It certainly has some connection to what previously said, like regular programming in C++ and macros. But template C++ programming, it also can be seen as a pure functional programming. I don't have slides for that, but if you open a common Boost library, any of them, you will see a lot of template magic, and a lot of that template magic is pure functional programming on the level of types. There are many various tricks with templates in C++, which are generics. C++ templates are generics, but also you can do function application, you can do calculations on the types like integers, addition, subtraction, and etc. So yes. And also C++ has const-x per sublanguage and OOP sublanguage. C++ is very, very difficult. API says it's not pure. Template programming, you mean? Well, maybe, but I would say it's much closer to be pure than everything else as in C++ and in other languages. The only pure language from all of I'm displaying here is Haskell, but other languages more or less, well, maybe even Rust can be pure in some sense. Yeah, so C++ supports lambdas, you see that. C++ supports first-class functions, those functions that can be moved around and they can be stored into values and they then can be passed to another functions. API says no, like actually not pure by definition. You can side effect all over the place. You mean when doing template programming? Because template programming is compile time programming. It doesn't exist when you run the program. It only results in another program when compiled. In Haskell, you actually have template Haskell, the same name mostly, right? Templates in C++ and template in Haskell. And template Haskell can also do input-output. It's not pure in this sense. You can write files while compiling. You can rewrite code of your program while compiling. You can implement many crazy things while compiling, but we still can say it's pure, more or less. More or less. API says yes, just because it's compile time doesn't mean you can't do side effect. Side effect don't only occur at runtime. Depends on how you define side effects, right? If it's writing to memory and reading files or doing HTTP, then sure. If it's something else, depends on the definition. But yeah, again, it's a definition, well, definition depending discussion. API says that's the whole reason behind sanitized macros and the like. All right, sure, no problem. I'll still prefer to say it's pure template, pure functional programming, more or less, compared to other programming. You know, you can argue that templates in C++ are not generics, right? And you can argue that concepts in C++ are not type classes, but that's hugely depends on our agreements on the terms. So let me return to the narrative. So yes, there is a so-called std function. You can put functions into it. For example, I can put add to that. In C, we could pass pointers to functions, and in C++ too. And in this sense, we did functional programming. We could pass a pointer to another function, and that function could call the passed pointer, passed function. So in this sense, it's functional programming, more or less, right? Also, yes, C++ certainly supports high-order functions because it's just a value, you can pass it here and there. And execute function is therefore a high-order function. The terminology is first class means you can move it, high order means it takes another functions as arguments. API says, then you're using words wrong. Well, we can discuss that later. So yes, let's move on. Also, C++ has a rich story regarding real functional programming, like hardcore functional programming. Eric Nibbler implemented a library that is called ranges. Well, actually, we can even track the idea to more earlier implementations that exist in number, and some of them even exist in the Boost libraries. Boost is a huge collection of various libraries, and ranges is not the first approach to real functional programming with transformations, with specific combinators and language for that combinators, but it's in the standard right now. Essentially, ranges serve the same purpose as LINQ in C# does, and Streams API in Java does. And ranges, like you see here, they are taken from Haskell. Well, not taken from Haskell, but inspired by Haskell. Many combinators have the same name and the same structure. Many high-level ideas embedded into ranges also taken from Haskell. That's not my fantasy, because I personally asked Eric Nibbler what was the inspiration for that, and he says yes, it was Haskell. It was Haskell for sure. Yeah, and there are many other things in C++, for example, Boost HANA, which copies Haskell's approach to type classes, to hierarchy of various structure like monads, functors, and applicative, and what's not. I don't really remember. I haven't used it, but I've seen it. It's quite mind-blowing. So yes, functional programming in C++ exists, and it's rich, but I don't think it's so popular. It may be it's maybe used in some small occurrences because C++ is too vast for those features to be applied all across the industry. So maybe some enthusiasts use it, maybe some don't, but it's there, and it's in the standard, and you can try it. And it's very verbose, actually, very wordy, and not quite convenient to do so. Remember the one-liner in Haskell, right? This is what it looks like in C++. Yeah, even if we remove some optional syntax from here, it still will be too verbose, too wordy, too boilerplatey. Yeah, in C#, there are also lambda expressions. They look like this, and they support first-class functions with the func class. It's kind of the same as std function in C++. You can put lambdas, you can put other functions to the C++ developers sometimes refer to this as delegates. Why not? Delegates have been implemented in C# earlier than other functional features, if I'm not mistaken. So kind of they implemented functional programming before they implemented functional programming, actually. So yes, you can pass those funcs around. They are first class, and there are high order functions for sure. But the most interesting thing in C#, it's LINQ. LINQ, well, it's not just only one approach to collection processing. There are several syntaxes to processing. One syntax looks like SQL in C#. Another syntax looks like this: chain of calls. You can chain your calls in a functional manner. In here, I separated those calls into separate functions, right? But also I can do it one line. Actually, this is kind of the same as in Haskell. You can chain those calls and pass arguments around, and it's very convenient and very spread, very used in C#. So C# developers actually use functional programming quite a lot. What's else interesting? There is a combinator called select many, and it expresses some monadic behavior within this library. I will not be able to explain it in full, but we can say it's enumeration, kind of enumeration with some transformations. In Haskell, it's a list monad, more or less. In C#, it's a select many method, which is actually monadic bind. It's a monadic bind. So yes, we even have some monads in some languages. And surely there is a literature about functional programming in C# because it's very popular, and you can learn it if you want. And it's even used in various technologies in C#, in several frameworks, maybe in several libraries. Those have some functional programming flair. So yes, it's not just some side technology. It's quite natural to C# and .NET. Not saying about F#, which is a functional language, actually. Python. In Python, a story is very interesting because we have functions in Python that can be themselves passed into another functions by having their names. If you have well, I don't have a definition of a function here, but once you have the definition, you can pass that definition to another function like it was a pointer to function, and it will be called it will be called nicely, like in C a pointer to function. So functional programming was well, more or less embedded into Python from the beginning. It just wasn't called like that. But certainly there are specific functions to doing collection manipulation, for example, filter, map, and at some moment they were in the main libraries right in front or before the developers eyes. But then Guido van Rossum said, I don't want them here. I want them in far place. Please don't use them. It's not idiomatic to Python. It's not good. So he said they moved those functions into a var module, but they are more or less accessible anyway. What's else interesting? There are list comprehensions and generators. You can define a way how to generate a collection instead of defining the collection itself. Many ways to define that. And but if we take a look at the syntaxes, it looks very similar to what Haskell has. In Haskell, you also have list comprehensions, and the syntax is very similar. You can do very interesting things. You do not need to construct those values with loops or something like that. If you know how to do generations and list comprehensions, it will be like easy. For example, we want a square for all even numbers, where even numbers are all numbers from numbers, those that have no well, they divide to two without the how to say completely, totally. I don't know the word in English, sorry. But functional programming in Python is culturally not very appreciated, just because Guido says we don't need it. I don't think they really don't use it. I think they do, but they prefer to not talk about functional programming. At least what that was the status like 10 years ago, maybe. But maybe there are heretics who still do functional programming in Python, so you can learn that. Don't tell Guido, because, well, look at that bridge. It will be cool to build this bridge and to walk there. Yeah. Rust. What do we have in Rust? We have a lot actually. Lambda expressions for sure. Again, this is lambda that adds 1. Also, first class functions, higher order functions, and collection processing. This style of having those functions called with dot is called fluent interface. And you can do that in C++, in C#, in Rust, in Java, in Scala. Fluent interfaces allow you to do this chaining. It's not very reliable method, because what if some intermediate thing is broken? Then the whole chain will be broken. But still, it works for usual collection processing, right? Rust is more or less convenient, but still is too wordy, but less wordy than C++. Again, it's the same function that selects even numbers and squares them. What's more important, Rust supports algebraic data types, and those ADTs are very good. ADTs is another feature from functional programming, especially from Haskell, that must be in every programming language. Why? Because defining domain models with this feature is much simpler and more consistent than doing that with classes, with structures, and with records and whatever. With enums, algebraic data types replace everything what I named, and they provide a more convenient way to do that. Well, in Rust you can define them. You can have you can have, for example, a binary tree data type that has only two value constructors here, empty and node. Empty denotes the tip or maybe leaf if you want to, and node defines a value stored in the node and two branches. Enums are ADTs, says API. Yeah, enum is ADT here. That's not a very widespread name for ADT, and in Scala you would hear about ADTs as case classes. In Haskell they are just ADTs, but in Rust this is a terminology. And also ADTs are very powerful when you have pattern matching. You can deconstruct your value into this or that option if you are talking about binary tree. This hugely reduces boilerplate and improves reading of the your program, because it becomes very informative. And also it provides some type safety. In C++, to do those ADTs, you need to combine several features. For example, std variant, and maybe union will be very bad for doing that value or that value. It works like that, but treating it as a part of algebraic data type will be disaster. So union in C++ will work but there is std variant and there are structures. You can construct a kind of ADT, but it won't be convenient. Rust does it much better. And also it supports immutability in some form. And in general, it takes a lot of features from OCaml that are they are similar to features in Haskell, and you can learn a lot of functional programming from Rust. Unfortunately, we don't have much literature. Maybe it's a spot, a blind spot to fill, a gap to fill. Maybe you can write another book to be more appreciated in that community, because they love functional programming actually, and they love type-level programming. And finally, I want to tell you about JavaScript, because it has some strange history. Again, it's a functional language. Well, it seems JavaScript is the most popular functional language ever existed. And most of the frameworks and libraries in JavaScript use functional programming more or less to some degree. You can do regular functional programming like collections, transformations for sure, filter, map, reduce, whatever you want, lambdas, there is everything. You can pass functions. It's a dynamic language, right? And you can pass function names as first-class functions, like in Python. And I don't know if it's a practice to see, but API says they just empty singleton constructors, okay? And API says, what's your definition of functional when you say functional programming? Functional programming is essentially a combinatorial programming. When you have functions that can be passed into another functions. Nothing else can be added. Purity is not necessary for functional programming. Only this function application and first class property, that will be enough for FP. Yes, because functional programming was seen like only those three functions: map, filter, and reduce. But with some time, we decided, not we decided, but the definition has shifted, and we included more things into functional programming. API says, so if it has higher order functions, then it's functional. I would say we don't need to call our languages functional, object-oriented, or something like that, because the notion of paradigm is kind of obsolete. All the same languages have or support that or that another style of programming. If it has high order functions, it supports some functional elements. Yes. So in this sense, it's not a functional language, but it has elements of functional programming. We can talk about styles, and it's the fact that those paradigms, they merged. Many features in many languages are not they cannot be separated from another features. If you have an object-oriented feature in Scala, it mostly works as a functional feature too. There are objects in Scala, and they can work as functions. The worlds have merged. So saying this language is functional or procedural or object-oriented mostly doesn't make sense anymore. They are multi-paradigm and support many various styles of programming. So there can be various approaches, right? We can say this approach is more functional than that because it uses immutability. But still there are statements. In C++, so you can do const, variable, some functional call that is also const, and another const value, another call. This is a step-by-step program, but it uses immutability, and therefore it uses a functional idea. It's not functional programming, but it's element of that, right? API says, okay, so I guess I don't understand why you're doing a talk on functional programming being mainstream, then your definition is actually too loose to be useful. I don't want you to use the term functional programming. I want people to be more conscious about what they're doing. There are features, there are styles. You can choose that. You can do that in your preferred language. And that's it. And it's everywhere. This is the main point. Yeah, and by the way, JavaScript has a lot of frameworks that work with functional ideas or based on functional ideas. So yes, it's a lot of FP actually. They are also object-oriented in this sense because they use object model of JavaScript, but still. And it's known that JavaScript was firstly influenced by Scheme, by the definition of its creator. Scheme is a functional language, very similar to Lisp, more or less, and the language created took closures, which are lambdas, and some environments, not sure what was that in their definition. And initially it was planned as functional language, but then they've seen that it's not a very popular paradigm. It were 19th, right? And functional programming wasn't so popular as it's today, and it was felt too marginal. Scheme is Lisp, says API. Sure. Again, Lisp is common Lisp. Other are Lisp-like languages. The same way as there is Haskell, and there are, for example, Idris or maybe Neo-Haskell or what else. So we can say they are Haskell, but they are not. And scheme, maybe whatever you want. A lot of books on functional programming in JavaScript. I was impressed when doing this research, so you can learn it, and I probably want to read some of those books too, because there is one in Manning, which is cool. So that's probably the whole, I would say, observation of the features, and we can talk about functional programming in large. Again, it's a matter of definition, but actually we see more and more applications of functional programming as engineering discipline. It was a source of inspiration for creating various technologies, but today it finally gets a discipline of creating applications, because object-oriented programming had enjoyed this discipline since maybe 1990s, right? There were books like Django 4 or maybe object-oriented design and other books like that, design patterns and design approaches, architectures, and etc. and etc. It was an engineering discipline, and we created it to help businesses to build big applications with teams, scalable applications with certain qualities, for example, testable, extensible, and etc. and etc. There are many various requirements to big applications, and doing engineering way, it doesn't guarantee you to get a good quality code, but it reduces risks of getting unsupportable, very badly maintainable code. So engineering discipline is a risk management discipline, and it was elaborated for object-oriented and imperative programming. Functional programming wasn't like that. It was lagging behind quite a lot. But today we can say we finally see it's going into the direction, and it offers many ideas which are not weaker than OOP ideas. And there are methodologies, there are design patterns, unique functional idioms and ideas which can be applied. But this is a very big topic, and probably we need to make another talk about that. All right? But still it goes there. But also, we do kind of functional programming here and there. AWS Lambda, why it's called like that? I'm not an expert at all, but maybe it's called like that because you push some code that will be running on that instance and will be doing some work for you. It's not necessarily a functional code, but the idea of providing a code seems close to functional programming, right? Excel is a kind of a pure, more or less, pure functional language if we are talking about cells and functions to those cells, over those cells. And even accountants did functional programming, and they do it a lot, really a lot. There are also various approaches like ATL, extract, transform, load. It's a pipeline, and pipelining is one of the properties of functional programming. You do data transformations all the way, and you can load and upload those data from here and from there. Unix pipelining, more or less functional programming, more or less. Yes, it's not pure. It can do effects, but the idea is combining different combinators, right? API says it's called AWS Lambda because it provides ingress and egress for ETL pipelines, and it's effectively piping your data to an egress after some transformations. As I said that, right? We also can say smart contracts, which are mostly imperative scripts, but the idea of them being immutable transformations of blockchain is a functional idea. So we see here a merge of two ideas. Scripts they are mostly imperative, right? Take that, change that, and upload here and download there. But they will be only applied once to arguments, to the same arguments, and they will produce only one specific result that will not change if you again apply those smart contracts to the same arguments. It's a pure transformation of previous blockchain to a new blockchain. So yes, it can be seen as a functional architecture in large. So that's probably it. I would encourage you learn more functional programming. It's fun, and maybe participate in building functional programming as a discipline, as an engineering discipline, because this is what the industry needs it. Maybe it's a bit late, right? Because it's 2024 and all the systems are already written. Maybe we don't need to write more software and use more paradigms. But maybe we will see another IT evolution or maybe turn that will allow us to apply new ideas to new applications and new software. So that's it for today. My Masked Web says, is Excel or Google spreadsheet better? That's a holy war question, because who knows? Well, I think Microsoft Excel is much more feature rich. It's huge. It's just enormous. But Google is more convenient for me personally, because I don't work with Microsoft products. I don't work with Windows mostly. I don't work with Office. I need something more. It's not open source, but more accessible for me personally. But there is LibreOffice. API says, my brother increased 19% of what you said was bullshit. Why talk about stuff you don't know? Yeah, sure, of course. I am OT. Yeah, no problem. Good luck. That's it, probably. And you to decide if what was said bullshit or maybe not. But for today, it's all. Thank you and bye.